All right, we are ready to do page 4. Again, page 3, all calculations. So you could be done all the way up to this point. This page has 1, 2 data tables. They're called data table 4 and data table 5. So you can add those to your report, or again, if you made a copy, just stay with us, and we are going to continue to do the lab here and share the results that we have. Okay, so whoops, I dropped my leather samples. I'll be right back. All right, found my leather samples. So this is what the shoe itself is made of. They buy their leather samples at Red Wing Shoe, some from the tannery here in town, and some from other businesses. So one of these is waterproof and one is not. In the data table 4, so hopefully you've read the whole data table and you see what we're going to do. We have sample number. See where it says sample, it's a little hashtag symbol? We're going to have sample number 2 because it has 2 dots on it. Okay, so it's got those 2 dots. And then this one has 4 dots, so that's going to be number 4. So sample number 2, the mass, 1.35 grams, 1.35 grams. That's when it's dry. All right? And sample number 4, it's a little bigger piece, and it's 1.59 grams. 1.59 grams. Okay, now, what we're going to do to help weigh these down is I'm putting a paper clip on each one to weigh the sample down because they won't sink naturally. And it says about half full of tap water. So I'll just kind of put these where you can sort of see them there. So about half full, half full. This is not an exact measurement. What we want to do is we want to just soak them in the water. Okay, so I'm going to, hey, Mariana? Mar? Can you start the timer for me for 5 minutes? Yeah. Okay. So Mariana's going to set the timer for 5 minutes on the stove. You started? Yeah. Okay. There we go. 5 minutes. We're going to soak those as it says for exactly 5 minutes, and we'll take them both out at the same time so that one doesn't stay in the water longer. And then we'll see which one is more resistant, or what degree of resistance are they. So we'll eventually, after the 5 minutes, we'll do the mass after. And in the meantime, we're going to drop down to the very bottom, the very last data table here. Okay? And we might have to stop in the middle if our 5 minutes runs out, but we might as well make good use of our time here. We're going to use this device, which Red Wing Shoe donated to us. It comes in this nice handsome little case right here, and it's got a gauge on it. And if you will look, it has a little tiny sort of probe at the bottom there. There's a little piece of metal sticking out that you can sort of tell how squishy something is. So that pushes into, and you can see as it does that, the gauge changes. So what we have is some samples this is the heel of a boot. We just cut that on a bandsaw, actually. And then there's this location right there, A. And it says that you're supposed to take the 1600A Rex gauge, which is what this is, and put it in there and allow it to set. So I'm going to put it right inside that circle, and I'm going to kind of allow it to set for 10 seconds. Okay? So, and then I'm going to give you guys the reading for this. So I'm just being careful not to move. And 35.2. 35.2. Now notice it says use the letter A for units because it's a A style Rex gauge. So that's what they do. They call this 35.2A. All right. So that's kind of a measure of how squishy it is. Now here is the sole of a shoe where we've cut it off this way. So you want to kind of measure for comfort how squishy is it sort of pushing down with your heel for comfort. So this should be squishier, squishier, which gives you a lower number on the Rex gauge. Let's see if that's the case. So I'm going to let that settle in for 10 seconds, being careful not to move. Okay, and we get 26.1A. This is for sample B. 26.1A. Okay? All right. Now, when we took the tour, they took this polyurethane and isocyanate, two compounds, and they put them in this cup here and then filled it to the top. And you can see that's just actually bouncing off the table. Nobody's going to rip that. This is a really strong material. So then we took and we cut this right in half to sort of take a look at this and look at the open exposed end. So we're going to look on the inside of this cup sample that they gave us and see what that value is. Okay, we're going to wait 10 seconds. And the answer is 24.4. 24.4. 24.4A. Is that the timer, Mar? Okay, so that's perfect timing. We've got the bottom data table, and we are now ready to remove both leather samples. I'm going to take the paper clip off, and then it says to kind of just get the majority of the water off, just so that it doesn't get too sloppy on the scale. So as it says in the instructions, that I'm just seeing how it's worded. Lightly dry the surface with a paper towel. Do not press. Okay? So I'm just lightly drawing the surface, and what we're going to see now is what happened after these leather samples sitting in water for 5 minutes. So this is sample number 2. Okay? So go back up to data table 4, and data table 4, you will see that it is a value of 1.60 grams. 1.60 grams. So the mass went up from 1.35 grams. So that is an indication that it did take on some water. Okay, so let's see what happened to sample number 4. We'll drop that on the scale. Sample number 4 is 1.67 grams. Okay, so as you can see, it did not go up nearly as high as the other one. And you might have guessed that from the camouflage pattern that this is the waterproof. So it went up. But they want to quantify that. They want to compare this to another waterproof shoe. So you use the equation in number 7. You take mass after minus mass before divided by the mass before. And then put that for the percent of water absorption. What will allow you to do with this, so you don't have to stop and go, oh, that's only one significant figure or two significant figures. You can use 3 sig figs for your percent of water absorption. So I'm making myself a note to tell that I told you guys that. So I want 3 sig figs for the percent of water absorption. So you got some calculations to do on that. Okay? You have now finished the Red Wing Shoe Lab, and you've done your very first raw material report. That is the type of work that people get paid a lot of money down there at Red Wing Shoe to keep things on track. The density calculation of the polyurethane, they told us a story that they made a calculation error, and they started putting these chemicals together and making the sole of the shoe, and then they got the shoes out and they bent them and they cracked because the density had been miscalculated. And I don't remember the exact number, but it was over $100,000 mistake that was. So do you think those sig figs and those digits and the rounding and the detail is important? Yeah, we really learned that a lot. And we also learned that they do a lot of conversions between metric and the United States system. A lot of dimensional analysis like we did yesterday. It's a very realistic skill for chemists. So it was really great to get out there in the working world and see what they're doing at a wonderful company that we should all be very proud of, Red Wing Shoe. I don't get any pushback. I don't get free boots for saying that. I just think that I was very impressed with how things were run. They're very careful, and they take a lot of pride in putting out a product that's different than someone racing to get it off of the assembly line as quickly as possible. So right now, you're going to take that same pride in your raw material report, which is worth 50 points, and you're going to go over it with a fine-tooth comb, make sure every number has a unit after it, a label of some type. That's going to be a lot of check marks if you forget that. Okay? So let me repeat that. Every number in this whole lab report needs to have a unit behind it. Okay? All right. So just read the daily instructions for due dates and so on. And congratulations on getting the lab done.